Welcome back, learners. Now let's look at our line graph. A line graph and a broken line graph are graphs where points are joined together. When plotting the graph, intervals must have equal divisions. Then a line graph represents continuous data which can be measured. So let's look at a line graph. We have given there an example of a line graph. We have a temperature for the 22nd of February, whereby we're given the temperature in degrees Celsius and also the time. Then Lihle wants to choose an outfit for the day. She analyzes the graph given alongside. At what time was the temperature at 36 degrees Celsius? We go to our temperature, we check 36, here is 36 degrees Celsius. Then we check at what time was that temperature at 36. It was at 12 noon. So it was at 12 o'clock. That was the time. Remember, whenever we write our time, we have to write it as time, not as a duration. So it means it was at 12 o'clock. Then we go to question 2. Calculate the difference in time when the temperature was at 32 degrees and at 36 degrees. So there is the time at 32 degrees and the time at 36 degrees. So we have to check at what time was it at 32? It was at 10 o'clock. And then what time was it at 36? It was at 12 o'clock. So we have to find the difference in the time. So we're going to say 12 o'clock minus 10 o'clock. So what is the difference in time? It is actually 2 hours. So that is the difference in time. We are writing it as a duration. Then question 3. What type of graph is represented? What type of data, is represented by this graph? What type of data is represented by a line graph? It is the continuous data or the data that can be measured. You can say continuous data or data that can be measured. Let's say you forgot the word continuous. As long as you've written the data that can be measured, then you are still correct. Then we have a broken line graph which represents discrete data, which is data that can be counted. Then we are given an example there of a discrete data. It says there it's a graph on the bus trips as well as the number of people that were in the bus. The graph given below, the graph given alongside indicates the number of people in different bus trips. Question 1 says, which bus trip had the most number of people? So we have to check where the graph was at its highest. Then that gives us the bus that had the most number of people. So if we can check the graph at its highest was at bus trip number 6. So it's bus number 6. It's trip number 6. Then question 2, how many people were in the 5th bus trip? We check bus number 5. Here is bus trip number 5. How many people were there? There were 40 people in there. I'm going to write people as PPL. Then question 3, calculate the total number of people in bus trip 2, 5, and 6. 2, 5, and 6. So in bus number 2, how many people were there? We had 20 people. In bus number 5, we had 40 people. And then in bus number 6, we had 60 people. So this you can do it manually without punching on your calculator. 40 plus 60 gives you 100. 100 plus 20 gives you 120. So we had 120 people in the 3 bus trips. Express the number, question 4, express the number of people in bus trip number 2, there's bus trip number 2, as a percentage of the number of people in bus trip number 6, as percentage of people in bus trip number 6. So in number 2, how many people were there? We had 20. In number 6, we had 60. So we had to express it as a percentage. So it means we're going to say 20 people in bus number 2 divided by the 60 people that were in bus number 6 multiplied by 100. Why 100? Because the percentage is always out of 100. So what is 20 divided by 60? 20 divided by 60 multiplied by 100. So we had 33.3%. Then we move to the next question. Question 5. Describe the trend of this bus in terms of the number of people. Describe the trend. When it say trend, then you have to check that in bus trip number 1, we had more people than in bus trip number 2. Then the number of people increased from bus trip number 2 up until bus trip number 4. Then the number decreased from 4 to 5, then it increased again from 5 to 6. So we actually had a fluctuating number of people in all the different bus trips. So that's how you explain the trend. So you say there was a decrease in number from bus 1 to 2, then we had an increase in number from 2 to 4, then we had a decrease in number of people from 4 to 5, then we had an increase from bus number 5 to number 6. Okay, let's write down our answer. So seemingly that we've already identified that we're going to have 4 trends. So this is going to be trend number 1, number 2, number 3, and 4. Then we write it down in bullet forms. So we've got the first bullet is going to be, we have a decrease in number of people, sorry, let me write it correctly. Decrease in number of people from bus trip 1, from bus trip 1 to 2. Then the next bullet is increase in number of people from bus trip 2 to the increase from bus trip 2 to trip 4 Then we had a decrease in number of people from bus trip 4 to 5, from bus trip 4 to 5. Then the last trend, it is an increase in number of people from bus trip 5 to 6. So the moment you've identified the number of trend, then it becomes easy for you to write it in bullet forms. Then you write it like that according to the number of trends that you have in the graph. Let's move on to question 6. How many people will be in bus trip 5? In bus trip 5, if the number of people increased by 15%. How many people were in bus 5? We had 40 people. So we are anticipating an increase of how many? Of 15%. So remember, percentage increase, we're saying the number of people that are there, they're already 100%. But if we are increasing them, it means we are adding an extra 15%. So which becomes 115%. Then it means the increase will be 115 over 100 because this is a percentage. Then how many people will we get in bus trip number 5? We'll say 40 multiplied by 115 over 100, which gives us 46. So we'll have 46 people now in bus trip number 5 instead of 40 if ever it has to increase by 15%. Then another way of doing it, you can say 40% multiplied by 15 over 100, which is the 15% that we want to increase the number of people with. Then what is 40 multiplied by 15 over 100? It gives us 6. So it means the extra people that we have to add in the bus are 6. So what is the total number of people that will be in the bus? We'll say 6 plus the 40 that had already been there. Then what is 40 plus 6? It gives us 46 people, which is the same as the one that we got above there. Question 7. A bus can only carry 65 people. This is the maximum number of the people that can be in a bus. Pearl claims that only one bus will be needed if the people in bus 1, we have 1, bus 3, and bus 4 are combined. Verify her answer. So now in bus 4, yes. So how many people are in bus 1? It's almost in the middle, so we'll assume that it's actually 25. So we have 25 people in bus 1 plus the people in bus 3 also in the middle, so we'll assume that it is 35 plus 35 plus the one in bus 4. The ones in bus 4, they are already 55 because we are assuming that it's also in the middle. So we have 55. So when we add all these people together, we get 25 plus 35 plus 55. It gives us 115. Now remember, Pearl's claim was that Since a bus can only carry 65, she was claiming that only one bus will be needed if we combine the people that were in this bus trip, in these 3 bus trips. So we are getting that actually the number of people in all the 3 bus trips are actually 115. So that means they will never fit in one bus because one bus can only carry 65. So let's do the subtraction just to check if ever will we qualify for 2 buses or more. So when we say 115 divided by 65, subtract 65, we get 50. So we can actually do qualify for 2 buses because one bus can carry 65 and the other one will only have 50 people. So 2 buses will be needed. Therefore, her claim is what? Her claim is invalid. So her claim is invalid. Okay, so there we forgot to add her claim. So it's supposed to be her claim is invalid. Thank you for tuning in today for this lesson. I hope you had a lovely lesson and you understand pie chart and line graphs better and you are able to differentiate between a line graph and a broken line graph. Hope to see you again next time. Bye.